So I've decided, let's do another example about the if then. And the example we want to do is a very common one. So let's say you have points and then there's a pass mark. So you want to give people a certain kind of a grade or some kind of a remark. I already have the code here. We have this variable points. So if someone gets between 0 and 40, they have failed. If someone gets between 40 and 60, they have passed. If they get between 60 and 80, then they get a good remark. If they get between 80 and 100, that's extremely good. Otherwise, it is invalid. So let me copy this and run it and see what to expect. And I will start from here and then up to there, delete this bit. So let me add that. So if I run this, you'll see it gives us a result of passed, which is good because they have points of 55. Let's say we give it 155. Let's see what will happen. If we run that, it will tell us that we have invalid points. And if we put negative 99, let's see what's going to happen. If we run this, you'll see it also gives us invalid points. If I hadn't put this on, then we would have an error with this one. It would give us a result, but there would be an error. If I remove this bit, let me just show you by example, and then we have a point of negative 99, and I try to run this, you're going to see it gives us a value failed. So if I run this, it gives us a value failed because we have said that less than 40. What if there's another way we can do this without having to put that other one here? So with the if statements, we can nest them. And what we can do, we can say that we have an if within an if. So we want to protect this if. So let's say if we want to make sure that if x is greater than 0, actually let's make it greater or equal to 0. Greater or equal to 0, that is when this other will be run. That is when this entire code, the code that we've just added, will be run. So it ends here. There. So it ends here. So what this one says is if x is greater than 0 is greater or equal to 0, that is when the code that is in here will get run. So let's just run this with our negative 99 and see what is going to happen. So if I run this, compilation error function, I'm so used to x, this is points, not x, points. Then we run it again. So you see what happens here. This is false, but there is no way for it to know what to do. The if that is outside, I hope you're getting this. What happens is this if is false, but there is no else to handle what will happen. So this is where what we are talking about, which is defensive programming, comes in. So you add an else to make sure that there is a way for the false statement to be handled. So here we can say cout, Control V, points is less than 0. So if I run this again, it will give us this result. So you can see that this is very good for defensive programming, and defensive programming is nice where you expect users to give you a value. So if this was getting added by some user and they made a mistake, then you can handle that. You saw in the other two examples, there was no way for that to get handled. There was no output. So it's always very important to give people output. If there's some kind of an error, you give them an output. So I hope these two examples have helped you understand these conditional statements. So in the next part, we're going to start looking at loops, and so I will see you in those next videos.